It's now welcome back to our YouTube channel. So in today's class, we'll be talking about revenue maximization. In the initial class, we talk about the concept of revenue. So I believe we already have an idea about that. But these two, like the revenue maximization, is also a subject that we all have an idea about. Okay, so I believe during our secondary school days or in 100 level, when we talk about calculus, during differentiation class, when we're talking about maximum value and minimum value, whenever you're asked to find the maximum and minimum value, the first thing we often consider is the turning point, right? And for the turning point, that was where we say that when dy all over dx equals to 0 as turning point, that's condition for turning point, right? Then we now go on to state that for your minimum value, but that is when your the square y divided by the x square is, okay, I say for your minimum value is greater than 0. Like this means that we are differentiating twice. Whenever you differentiate twice and the value you are having is greater than 0, we say that it is what? Minimum, right? But whenever you differentiate twice and the value you are having is less than 0, we say it is what? Maximum, right? Same concept also applies to revenue here. Whenever you are told to find your maximum or anything with respect to maximum, the first thing for you to do is to differentiate and equate it to 0, like the condition for turning point. And apart from that, if your total revenue, okay, let me just say you have your total revenue as this. Just making an assumption. Can have X. If I'm to find the maximum value of my total revenue, what do I have to do? Differentiate, right? And equate what? 0. In the sense that for me to find my maximum revenue, I'll say that differentiate total revenue with respect to X. That's quantity. It should give me my maximum revenue, right? And I should equate this to 0. But there's something else that I'm going to observe here. This here is the same thing as something else. That's the TR divided by dx. Like differentiate total cost with respect to x. It's with respect to another concept in revenue, the theory of revenue. You remember, you said that MR is equals to the TR all over the x, right? So this here is something as MR equals to 0. At maximum revenue, your marginal revenue is equals to 0. That's the reason why under your cost concept, your revenue concept, you observe that we were taught that when MR is equals to 0, your total revenue is at saturation point or the bliss point, right? It's nothing from here. You can see that this same concept is applicable here. So that's how that is being derived. So that's why we often state that when MR equals to 0, your total revenue is at maximum. So in any question, if we're told to find the maximum revenue, all you just have to do is to differentiate. In other words, find your M out and equate it to 0. So let's take a look at a question with respect to that. Okay, we are told that if the marginal revenue is given by 15 minus 2x minus x squared, find the maximum revenue. Okay. So now back to the question. We are told that if the marginal revenue is given by 15 minus 2x minus x squared, that's MR equals to 15 minus 2x minus x squared. Let me confirm that. Find the maximum revenue. So remember, whenever you're going to find the maximum revenue, the first thing for us to do is to differentiate, right? That's finding our AM out. So that will be the first thing. So that will be the first thing for us to do. Although in this particular question, we're already given the what? M out, isn't it? We're given the M out already. So we can go on and find and equate to 0, then we solve. So remember, at maximum, your M out is equals to 0. So here I can have 0 equals to 15 minus 2x minus x squared. Do you agree with me? So moving on, this can be written as 15 minus 2x minus x squared equals to 0. Right? So this is a quadratic. I can rewrite it like I can write it in another form. In other words, you can try to multiply all through by minus. So we will rearrange it according to the power, like the power in their degree hierarchy. Like the one with the highest degree should come first and follow that format. You should come in this form, like your ax squared plus bx plus c equals to 0. So I want this should be in this view. So for me to do that, this here can be seen as minus x squared minus 2x. Here is plus AB plus 15 equals to 0. I'm multiplying all through by minus. Actually, there might be no need for it to go through the stress of solving. I'm going to solve this out, but due to the fact that our exam is likely to be OMR, from this point, you can actually get your answer, right? Due to the fact that you can impute this on your calculator, that's on your casio calculator if you have any. So all I just do here is change the mode. We observe that at 5 you have equation, something that looks like equation. We click on 5. Then at 3 you have ax squared plus bx plus c equals to 0. That's quadratic. We click on 3. The a here is talking about the coefficient of x squared. And the coefficient of x squared here is what? Minus 1. So you impute minus 1, where equals to, you add it there. And the coefficient of x here, that's b, is minus 2. You press minus 2, impute it here, you're having b. Then the coefficient of the c here, that's constant, it's 15. That's plus 15, just press 15. Then press your equals to. So you can see, remember, whenever you're solving quadratic, you often have two answers. You have x equals to 2 or x equals to minus 5. Using our calculator, we are given x equals to 2 or minus 5, right? But solving manually,
3 or minus 5?
3, x equals to 3 or minus 5. Thanks for that. But solving manually, here, like my product, I'm having minus 15x squared. And here I'm having minus 2x, right? So I'll look for two numbers. We call it sum of roots. And we call another product of roots, right? For the sum, I'm having minus 2x, right? And for the product, I multiply this, I'm having minus 15x squared. I'll look for two numbers in which I'm going to multiply, which will give me this. The same numbers, I'm adding them up, it will still give me this. Let's consider 5 and 3. You agree with me that 5 times 3 is going to give me 15, right? And 5 minus 3 will give me what? 15. But let's add plus 5 RB minus 3 RB. And let's add the variables in the sense that plus 5x minus 3x plus 5x minus 3x will it give me minus 2x? So split means I have to swap this minus 5 plus RB minus 5x plus 3x will it give me minus 2x? Minus 5x times minus plus 3x will it give me minus 15x squared? So split means this I can easily substitute it with the value here. In other words, rather than writing this like this minus 2x, I'm going to re-express it as this me having minus x squared minus 2, okay, here minus 5x plus 3x plus 15 equals to 0. Because of minus 5x plus 3x, something as minus 2x, isn't it? So group into two graphs. Group into two graphs in the sense of you having this. By grouping into two different graphs. So grouping into different, now moving on. Remember, you're going to group into two graphs, something that look like graph. I believe you know how graph look like. So take a look at this particular section. Something is common in that graph. What is common in graph? I think it's two dots. It's always two dots are always common in both graphs. But take a look at this. You observe that something is actually common here, which is what? X, right? And apart from that, you observe that both of them have minus. So what I can say that factor out minus x. Remember, we are factorizing, that's what we are doing. So you have to factor out minus x, like let minus x be outside, like your ex-boyfriend. Then you have a graph. How do you factorize? I believe you have an idea about that, so I may not dwell more on that. If you are factorizing, what you have in the content, you divide it by anything outside. In the sense that I'll be having minus x squared divided by what I'm factoring out, minus x. Then here, minus 5x divided by minus x. Then close your graph so they won't see the content. Then plus, and if they look at this, is anything common?
Yes.
What's that? 3. Exactly. You observe that 3 is common here and 3 is also common here. So you can factor out 3, me having plus 3. In the sense of 3x divided by 3 plus 15 divided by 3. Then close the graph so they won't see the content equals to 0. So now let's simplify this. You are having minus x into the bracket. Minus can also have minus, right? X are 1 and x gives us this, right? So here you're having plus x. Then minus can also have this minus. Changing this to what? Plus. Then this can also have this. You're having 5. Then plus 3 into the bracket. 3 can also have 3. You're having x plus 3 here 1, 3 here 5. You're having 5 equals to 0. We observe that if I should expand this graph to see the content, I'll be having this value. Look at it. Minus x times x minus x squared. Minus x times plus 5 minus 5x. Plus 3 times x plus 3x. 3 times 5 plus 15. So still the same thing. I just want to factor it out. And by doing that, you observe that the content I have here, the same thing as content I have here. So you can pick one of them and group these two together. In the sense of having x plus 5, since they are the same, just pick one. Then group these together. You having minus x plus 3. And this is the same thing as me writing. Okay, let me write it that for I don't want to confuse you guys. I want to express it as 3 minus x. But let's look at this, do the same thing. Then equate to what? 0. So here, you are, so now moving on. This here is the same as me stating that x plus 5 equals to 0. Or x minus x plus 3 equals to 0. Right? So, try to solve like term. This should move to the other side. X, whenever plus crosses over an equality sign, changes to the opposite, right? Equals to minus 5, right? And here, minus x equals to minus 3, right? So here, this cancel out this. That's divided both by minus 1. We are having x equals to 3. Therefore, x equals to 3 or minus 5. And that was exactly what we had where we solved using our calculator. So, this is the fact that the exam might be multiple choice questions. No need for you to go through all this stress. But from this point, just input it on your calculator, you have your answer. So here we're taking a look at quantity. Quantity can never be negative. It's always positive. So we are going to disregard the negative answer we have. As a result of that, we will say that our x is equals to 3. This is our maximum quantity. Our maximum quantity. This fact that you can't have a negative answer, we are going to disregard this. The minus 5 will be disregarded, right? So we are told to find the maximum revenue. So for you to know, we already know the the maximum quantity. But do we know the revenue function? You observe that from the question given, we're not giving the revenue function. Rather, we're giving the what? Marginal revenue, right? But we can actually find our revenue function. In the previous video, we stated that total revenue is equals to the integral of marginal revenue with respect to what? X, right? So if you're giving marginal revenue and you're told to find the total revenue, all you have to do is to integrate your marginal revenue, then you add your what? Total revenue. Same thing we're going to do here too. So our total revenue will be equals to the integral of 15 minus 2x minus x squared dx. So now let's move on and integrate. Remember how to integrate. Add 1 to the power, divide by the result of the power, right? And here, what's the power of x in this 15 here? We are going to that it is 0, right? This 15 is the same thing as 15x raised to power 0. Remember, anything raised to power 0 will give you what? 1. Your boyfriend T raised to power 0 will definitely give you what? 1. So this here is the same thing as 15 times 1. Which will still give me 15. So, applying the process of integration, I'm having 15x, 0 plus 1 abi, then divide by the result, 0 plus 1, minus the power of x, and this 2x is 1, right? I'm having minus 2x, 1 plus 1, divided by 1 plus 1, minus, and the power of x here is 2, right? I'm having x squared plus 1, divided by 2 plus 1, plus what? Plus what?
Nothing.
Plus what? Okay, initially, on the norm, we ought to have plus k, right?
Yes.
But in the previous video, said that under the concept of revenue, whenever you produce nothing, when your output or your quantity is 0, sorry, quantity rather, whenever your quantity is equal to 0, like you producing nothing, your total revenue will always be 0, which makes your constant to be what? 0. So under the concept of revenue, we often disregard the constant, due to the fact that whenever you are producing nothing, you earn nothing, which makes your constant to be what? 0. So we are going to ignore the constant. So simplifying this, we are having our total revenue equals to 15x minus 2x squared divided by 2 minus x cubed divided by 3. So let's simplify that. We have total revenue equals to 15x, 2 cancel out this 2, we have minus x squared minus x cubed divided by 3. Remember, we are told to find the maximum revenue. I already know our maximum quantity, which is what? 3. Just input this 3 here, you have your final answer. As simple as that. When x, remember, revenue will be at maximum when x equals to 3. At maximum, x equals to 3. So anywhere I see x, I'll fit in 3. So I'm having total revenue equals to 15 into the power of 3 minus 3x squared minus s cubed divided by 3. So meaning that we are having total revenue equals to 50 times 3, that gives us 45, right? And s cubed, sorry, s squared, that is 9, right? And s cubed, that's 27 divided by 3. So moving on, total revenue equals to 45 minus 9 minus 27 divided by 3. That should give us 9. So here you're having total revenue equals to 45 minus 18. And what was 45 minus 18?
27.
We're having our total revenue as 27. As simple as that.